Hello everyone, today we have a question of a spring mark system. Once again, we have a question from a mass spring system. Now let's read to the question. The ratio K over M of a mass spring system is given to be 4.0 Newton meter kilogram if the mass is deflected downward through 2 centimeters from the equilibrium position, given an upward velocity of 8 centimeters per second. Calculate the amplitude of the vibration and the maximum acceleration. Now we can represent our question with a schematic of a single mass spring system suspended from the diagram above and is being excited up and down. So for us to calculate the amplitude and the maximum acceleration, let's pull out all our parameters. We have our K over M to be 4.0 Newton meter kilogram. We have our initial displacement 2 centimeters, which gives us 0.2 meter. We have the initial velocity 8 centimeters per second, which gives us 0.08 meter per second. Now, by using the formula of this particular, which is amplitude A equals the root of Wn squared x0 squared plus Vo squared all over Wn, knowing that our Wn equals the root of K over M, that is the angular frequency, equals the root of K over M. So therefore, we have been given K over M to be 4. So that our Wn equals the root of 4.0, that gives us 2.0 radian per second. Now, by inputting our Wn, which is angular frequency, into this particular equation and the other parameters, we have A equals the root of Wn squared x0 plus Vo squared over Wn. That gives us A, which is amplitude, to be root of 2 squared multiplied by 0.02 squared plus 0.08 squared over 2. That gives us our amplitude to be 0.47 meter. That is 44.7 millimeter. Now, for us to calculate the maximum acceleration, first of all, by using the equation of velocity, that is s dot of t equals a Wn cos Wnt plus phi, which is phase angle, into bracket. Now, by differentiating this particular equation, that is our s dot, which will give us s dot dot, which is acceleration, we have negative a Wn squared sine into bracket Wnt plus phi. So s dot dot is known to be calculated by differentiating the velocity, which is s dot. So from here, you know that for us to have the maximum acceleration, our Wnt plus phi equals 0. So therefore, it is cancelled. So the equation remains our s dot, which is acceleration, equals a Wn squared. So therefore, by slotting the values, we have our maximum acceleration, which is s dot dot, to be 0.0447 multiplied by 2 squared, which gives us 0.1789 meters per second. Thank you very much.